Hi, my name is Shuchishmita Mukhopadhyay. I am submitting this project as part of my internship application. The project called Vaccination Data Analysis and Visualization. The full pipeline covers three stages. At first, I clean the data using Python. Then I made a dataset using SQL and a Python loader script. Then finally, I connect Power BI to make a interactive dashboard. So let's move to the code. Um, I will start with the data cleaning notebook. The raw data is separated in five um, data sets, five Excel sheets. That is coverage data, incidence rate data, reported cases data, vaccination introduction data, vaccination schedule data. The first thing I did was I loaded all five datasets and checked their column names because some had inconsistent naming. Then I checked for missing values and duplicate rows across the every tables. For data handling, I used different strategies based on columns, like like for critical identifier columns like country code and year. I dropped the row entirely. For numeric columns like coverage percentage or number of doses, I filled with the median so that I did not distort the data. And for text columns, I used a fill, that is forward fill. I also converted all year columns to integer, standardized country names to title, and um, validated that coverage values stay between 0 and 100. Finally, I saved all five clean datasets as CSV files. In this clean data directory, I saved all the cleaned datasets. So next part is SQL. I created a MySQL database called Vaccination DB with five tables, one for each clean dataset. Let me talk through the design. Each table has an auto-increment primary key for unique identification. I used appropriate data types cat3 for ISO country code, years for year field, decimal for coverage percentage, and begin for uh, large counts like doses administered. I also added database indexes uh, on the most commonly queried columns, country code, year, and disease or antigen, so that the Power BI queries run fast even with the large data. After setting up the schema, I wrote a Python script to load the cleaned CSVs into the MySQL database. Instead of importing manually, I automated entire process. The script handles something important like column names in CSV files did not always exactly match the database column names. So I built a smart column matcher that normalizes names by stripping spaces and underscore and comparing them in lowercase. This way, a column named country name where all the letters in the word is in uppercase in the CSV automatically maps to the country name where all the letters in the word is in lowercase and separated by a underscore in their database. For each table, the script turns any existing data, load the CSV, match the column, cast the data types, and insert rows. It also prints a row count and the end, so I can verify the data loaded correctly. So next, finally move to the Power BI dashboard. First, notice our core matrices. We maintain a global average coverage of 82.12%, while we have administered 320 billion doses. We are still facing a significant 22T coverage gap that requires strategic intervention. Looking at the sum of the incidence by disease, we can see that typhoid, rubella represents our highest areas of concern, significantly outstripping polio in terms of reported cases. The bottom charts highlight our distribution volume. Antigens like POL3 and DTP show the highest historical volume of doses administered. Next, now let's move from global numbers to geographical specifies. This map allows us to visualize the protection gap by comparing the coverage map on the left with the incidence map in the center. We can identify regions that are high risk despite of our efforts. If you look at the table, we have tracking by country. For instance, Zimbabwe shows consistent coverage levels above 80% throughout the 80s and 90s, providing the benchmark of regional stability. The critical question is, are these vaccines working? The dashboard provides the proof. In our primary trend chart, look at the relationship between green line and blue line. Green line indicates coverage and blue line indicates incidence. As coverage increases, we can see a corresponding sharp decline in incidence rates, validating our vaccination strategy. Uh, this center visual highlights misleads. It demonstrates how incidence fluctuates based on yearly coverage milestones. Outscattered plot helps us identify outliers countries where coverage is high but incidence remains unexpectedly elevated, signaling a need for healthcare infrastructure review. Next, we focus on the operational monitoring of our healthcare system. We are tracking a maximum incidence rate 69.10 K, which serves as a red flag metric for outbreak severity. The line chart shows a steady climb in dose administration, peaking around 2010, followed by more recent volatility that we must address to prevent a disease. The bottom maps uses density markers to show exactly where the highest concentration of active cases exists today. Finally, we use these data to drive future strategy and decision making. We have categorized our performance into high, medium, and low coverage groups. Our priority is the low group, where coverage currently sits well below the 50% mark. When choosing how to deploy resources, notice the strategic comparison for the MCV1 antigen. The door-to-door strategy has proven more effective than clinic-based approaches, achieving significantly higher coverage. Uh, so finally, to wrap up the project, this project gave me a hands-on experience with sorry, hands-on experience with a real end-to-end data pipeline. I cleaned messy data using Python, uh, designing and populated and normalized in MySQL database, and build interactive visualization in Power BI.